Good morning, everyone. Thank you for having me here. So we're going to talk about a very interesting subject that is on everyone's minds, probably most talked about fad right now, artificial intelligence and blockchain. And more specifically, what are the economic impacts? What can a business do? What can an entrepreneur do? What can a corporation do with these technologies? The question arises, why is artificial intelligence important now? Why are we hearing about it just for the last 2 years when for a long time before that we didn't? Ultimately, artificial intelligence has two basic fuels. One is parallel computing. The computers that we have at home, the laptops and desktops, are known as serial computing, and they're not very good at running what are called neural networks. Neural networks are necessary for processing AI. And neural networks are something some of you may have studied a long time ago, back in the 20th century, 1993 maybe. You may have heard the term neural networks, and then it went away for 25 years. But now, parallel computing became possible because NVIDIA created a product not even meant for artificial intelligence. It was meant for video game graphics, the graphical processing unit, GPU. It's the luckiest corporation in the world because it turns out the GPU can run parallel computing on it, and NVIDIA's stock price rose by 2,000%, even though it was from a market they were not even addressing. Luckiest company in the world. But the GPU made it such that we can now do neural networks 20 to 50 times faster than a serial computer. That's fuel number one. The second one, you can see, is big data. Artificial intelligence needs data to learn from, and we finally have an amount of data that matters. We say big data. Well, 2018 has a lot more than 2015, but what we have in 2021 will be a lot more than we have today. So it's always a bigger amount of data. But when you combine these two exponential trends, you suddenly have a return of artificial intelligence. And when we say exponential trend, that is why these things kind of happen by surprise. This chart is not to scale, but just conceptually. All technology is exponential, and humans are trained to think in a linear sense. And if you see from the chart, the exponential trend line is below the linear trend line for most of the time period. Then finally, 80% of the progress happens in the last 20% of the time. So it's behind, 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 until it suddenly breaks forth and becomes much faster. And since all technology is exponential, and artificial intelligence was a function of two different exponential trends, it emerged much faster still. And that's why it seems like a surprise, even though parallel computing as well as big data were both progressing on exponential trends, seemingly nothing happening for many, many years, finally exploding into view. So that is why we have artificial intelligence right now. But then the question arises, why do we keep hearing about artificial intelligence, and we heard about it in the old days, but it hasn't really done what people assume artificial intelligence would do, which is to be human-like? Well, more than any other technology, artificial intelligence is one that suffers from a redefinition problem, which is that whenever one form of AI succeeds, it's no longer called artificial intelligence. So that's not really fair, but as soon as it succeeds, it gets called something else. Some examples, you'll find this quite funny. In the 1980s, some of you may remember, there was told that when artificial intelligence can defeat humans at chess, then humans are obsolete. Artificial intelligence has suddenly surpassed humans in everything. Now in 1997, there was an artificial intelligence, Big Blue, that was defeating Garry Kasparov. You can see here, Garry Kasparov at the time was the best chess player in the world, and the artificial intelligence is beating him. And don't just look at his face, Garry Kasparov's face. Look at the face of the people in the audience. They were told that when this happens that humans are obsolete. So look how worried they are, their faces. 1997. But then that didn't happen, so okay, let's forget about this. Let's say that chess was too easy and we'll find something more difficult. And when artificial intelligence is better than humans at doing that, then we have a situation where humans are obsolete. So there's a game called Jeopardy in the United States and in some other countries, which is a trivia game. You have to answer questions, but you have to understand the questions subjectively, so it's more difficult than chess. In the 2000s, they would say, when artificial intelligence can defeat a human in Jeopardy, then humans are obsolete. Well, in 2011, IBM Watson, a supercomputer, competed against the two best human Jeopardy players. Both of the humans in the screen are like Gary Kasparov of Jeopardy, effectively. And you can see that the artificial intelligence isn't winning by a little bit, it's winning by a lot. It has $1 million and they have only 300,000, 200,000. So in 2011, artificial intelligence defeated humans at Jeopardy. They say, oh, Jeopardy is not hard enough. Let's find something even harder so that we can keep saying, well, when artificial intelligence does this, then it is better than humans. Well, what is a game harder than Jeopardy? There's a game called Go, which is only played in Japan and Korea. I don't think any of us here play it. It's considered very, very difficult. It said in 2010, when an artificial intelligence can defeat humans at Go, then it can be declared that artificial intelligence has surpassed humans. Well, 2016 happened. There's a program called AlphaGo, and it won. But again, okay, this was forgotten about. Okay, let's stop comparing it to games now. Let's compare it to something else. We've run out of games. We don't, but the world didn't change overnight. This was in the news one day. Next day, it's forgotten. So then what happens? Truth is, the last time there was a peak in what we call artificial intelligence was 1982, and after that there was something called AI winter. But in 1982, everything that we call a different name today was considered artificial intelligence. Calculators are a form of AI. It does arithmetic thousands of times faster than humans. It can do square roots and cube roots and all that. Imagine if you had to do that before there were calculators in the 1960s. Search engine, speech recognition, virtual assistants, computer vision, and autonomous driving. All of these were once considered AI. They got called something else. If someone from 1982 could see us in 2018, they would think we have AI everywhere. These are all the things we thought were AI. But as AI gets redefined out, that happens. And therefore we see that artificial intelligence is becoming like the air we breathe. We would only notice it if it were gone. And that's why the speed of change of artificial intelligence is greatly, greatly underestimated. Now, once you see how the speed is faster than we think, and how the progress is concealed, we have to think, what is the business of AI? How do we make money? Or how do we at least avoid losing money? Or something in between. There's many types of artificial intelligence now, and many tracks. Like, you may hear about normal artificial intelligence, and you hear about machine learning, more mathematical, more algorithmic. And then the most advanced type is deep learning, subset of that. Deep learning is when the AI finds a solution without telling you how it got there. And that is the most advanced type of AI, as I said, but also the fastest and perhaps the most useful for applications like medicine, circuit design, and things like that. Finding a solution without telling you how it got there, closer and closer to human cognition. And this is just the most common branch of artificial intelligence right now. There's other branches like artificial general intelligence as well, which is to try and mimic the human at every stage of development. And there's 3 or 4 companies doing that. And what is the worldwide artificial intelligence revenue, you can see? Well, right now it's only $4 billion or so. And while it's growing 50% a year and might get to $45 billion as soon as 2025, all this talk for something that's just $4 billion worldwide revenue? Why so little? Well, in addition to the very high growth rate, and the fact that AI companies pretty much have valuation 20 times revenue right now, for a number of reasons I will discuss. Note that each dollar of revenue here is reductive. Reductive meaning it's displacing $10 to $50 of revenue in the incumbent business that it is disrupting in and of itself. So each dollar has an impact 10 to 50 times that on the outside. Now this is a chart from CB Insights that discusses how many different sectors are being disrupted by artificial intelligence. You can see there's many sectors and a lot of companies in each of those that have gotten venture funding. But everything from marketing and sales to vision, autonomous vehicles, business intelligence, and even core AI is one that has 10 to 15 companies underneath it. FinTech, commerce, healthcare, and others. So more than 100 AI companies have collectively gotten $15 to $17 billion of venture capital to date. And these are just the biggest names, and if you are a business in one of these verticals, these are the companies you could go to get a business advantage or a cost advantage through artificial intelligence. And among the sectors being disrupted, as we saw, think of what the applications are. Medical diagnostics. The way medicine works right now, it's very outdated. You have to go to the doctor. He has to memorize everything and then tell you what you have. Even to go to the doctor, you have to make an appointment, you have to drive there, you have to park, you have to pay, you have to wait to see him. Then you have to go back. The thing is, no human doctor can ever know as much as an artificial intelligence possibly, because I can tell you in the United States alone, there's 20,000 medical papers published each year. No doctor can really read more than 100 of them. So no doctor can really know even a significant fraction of their own field. It's just not possible. There's a number of instances where you see a patient has a rare disease, and she goes to a doctor and multiple doctors, and they don't know what she has. Then she goes to IBM Watson, and IBM Watson finds the cure in 1 second, just because IBM Watson has so much data to draw from that the few people in the world with the same condition will have met them, whereas an individual doctor may not meet someone with that condition ever because it's too rare. There's just a very obvious advantage of diagnosis through artificial intelligence relative to humans. Pharmaceuticals. The biggest problem with pharmaceuticals is the approval process. In the United States, there's a Food and Drug Administration. It takes 10 years to approve drugs, but because of the research and development apparatus in the United States, there's not enough other countries that can compete in the pharmaceutical industry. That can change with AI because the data that AI can capture from each testing cycle can speed up the data reporting and conclusion drawing process. Therefore, you shorten 10 years to 3 years. Search. You know, we have no way of comparing Google search side by side, 2018 versus 2008 versus 1998 Google search. If you could, you would see how much improvement has occurred. Because there are 20 billion Google searches every day, and each one feeds more data into the engine, and now the Google searches have become more and more precise. And when a new type of search comes in, we don't even notice that it comes in, but then we can't live without it. Does anyone remember when Google once added image search? No, we don't remember when that came, but now if it went away, it's, oh, where's image search, right? Video search, patent search, news search. It improves a little bit every day, and we don't notice it. It's one of the best examples of that, because we just don't have a way of saying, well, in 2008, it was only this precise. In 1998, there was no image search. There was nothing. So there's continuous improvement through there. Autonomous vehicles, you've probably heard a lot about, but that is a huge application of AI. Can save millions and millions of lives. Cybersecurity. When AI is involved in cybersecurity and the hackers are human, then by becoming smarter than human, it starts to greatly supersede what a human hacker can do, creating very robust security. Legal and judicial, a huge industry, because what happens is that you have different lawyers all studying the same thing and looking up case law in different courts. Every court in every country in the world has a big backlog. And a tremendous amount of automation is possible because there's so much duplication of effort. Sales and marketing, if you notice, the recommendations on Amazon are getting more and more precise. It's often suspicious. How do they know so much? That tends to happen because of the AI engine, and Amazon.com collects so much data. Even though it's a mature e-commerce company, it's been around for 23, 24 years, yet its valuation more than tripled just in the last 18 months. It went from 250 billion market cap to now 950 billion in the last year, because the data became monetized through expectation of AI. Amazon's e-commerce business didn't change that much from 2017 to 2018. It's been around for a while. Why did stock triple? More than triple. Because now we're going into the wave of AI, as seen by how much data is generated by sales and marketing. Computing we talked about, but the ultimate is now happening. Use deep learning to design circuits itself. Circuit design is another factor, and another function that is very, very suited for deep learning. And when you have AI chipsets generating additional AI chipsets, you have a very self-propagating independent loop. AI used to generate AI chipsets faster and faster. That is happening. Logistics, there's a huge amount of data there. Tier 2 and Tier 3 locations can become part of global supply chains because of the immense data generated from each little package, each little loading activity and so forth. A huge amount of cost savings possible in goods shipping and things like that. And then retail and e-commerce, we talked about as well. The real benefit of e-commerce relative to brick and mortar retail is not just that you don't have to go there and the price is a little bit cheaper and you hire fewer people. That was just benefit number one, 10% cost benefit. The bigger benefit is the data. Brick and mortar shopping does not really generate data the way that Amazon.com does from shopping. And that is an insurmountable advantage. So those are the industries being disrupted by artificial intelligence. But one thing that everyone here hears about, everyone everywhere, because the media likes to talk about it, is AI and jobs. What is going to happen to jobs? What's going to happen to each of our jobs? Will there be jobs in the future? And this is an important subject because, remember, the media is in the business of scaring people. They'll never tell you something is good. The economics of media says that they're designed to scare you, and this is a very effective way of scaring people. AI will take away your job. There's no one to blame or anything. But anyway, this is a chart from McKinsey and Company. And each dot is not labeled, but each dot represents a profession in the United States. And the ability to automate is the vertical axis. And the hourly wage in dollars, US dollars, is the horizontal axis. And you can see about half of the jobs are very easy to automate, half are difficult. Now, when people see this, they get scared. Oh, I hope my job is not in the lower left-hand corner. Well, that isn't really the way to look at it, though. The way to look at it, what percentage of your tasks are being automated? If half of your tasks are being automated, as is the middle outcome here, well, you can do twice as much of the other half that is not being automated, right? Employ AI to do the more repetitive tasks. Do twice as much of the others. Maybe you'll get paid twice as much too by doing that. That's the way to think about it. We'll come back to that. But a simpler version of that chart, and this is where the media really scares people about AI, because that's the question that gets asked everywhere. Will AI take jobs? AI take jobs. Okay, so now there's two problems with a chart like this that the media puts out for Business Insider. Very simple chart, generated for a mass audience. So problem number one, which some people do point out, is that it's only showing you the jobs going away. It's not showing you the jobs being created. Technically, more jobs are created than are taken away. It's true that not everyone wants to be a software engineer or can be a software engineer, and retraining is an issue. That's true, but at least that problem is somewhat discussed. But there's a bigger problem. Look at the topmost jobs on this list. Telemarketer, truck driver, accountant, retail salesperson, technical writer. All private sector jobs. This is what the media is about. All private sector jobs will go away. There's no government jobs on this list. Why not? Why not those jobs? So keep that in mind. We'll come back to that in a few minutes. But if all these private sector jobs are being automated, why not government jobs too? Indeed. But now think about what automation does for jobs. It, in general, takes away a job, but the employer is saving that much money. The two are inseparable. Whatever job is being automated by AI, the employer is saving that much money. So then compete with the employer, because they have a high margin, right? This is the history of automation in the United States, and many countries are similar. The purple line going straight down is people working in agriculture. In 1840, you had 70% of the US population working in agriculture. 70%. Some were not even voluntary, some were slaves, but 70% worked in agriculture. Now that's come down to 2%. When 70% of people needed to produce food for 100% of people, I mean, each person's only producing food for themselves and half another person. 2 people producing food for 3 people, that's how low productivity was. Now just 2% produce food, and America has so much food that it exports food, and it has too much food even after that. the second line is manufacturing, industry. With industry, you see, okay, as agriculture went down, industry rose. There was a peak, 1950 to 1975, and then gentle decline. Not a complete decline, slight decline. Now, there's a lot of complaining, oh, manufacturing jobs went away, what will we do, what will we do? But the decline was relatively little compared to the loss of agricultural jobs. But then you see service jobs that just kept rising, rising, and rising outside of that. Service jobs are what the majority of people do now. It's up to 85%, 80%. And the worry is artificial intelligence takes service jobs, so what happens then? What is above that? Will there not be enough for people to do? That is the fear that arises, even though that has never been a problem before, so far. But we talked about agriculture from 70% to 2%, yet there's so much food produced in a country like the United States that there is quite literally a problem of too much food. But with manufacturing, what gets all the press? Think about this. Yes, manufacturing jobs have declined a little bit. It didn't decline a lot, as you can see, but it declined a little bit. And some people are very emotional about that. And it's an issue, oh, jobs for manufacturing unions, things like that. But look at productivity. The dollar output of productivity never stopped going down in the United States. It only kept rising. And notice you see that same exponential curve we saw in the beginning, exponential curve. And the doubling times are getting shorter and shorter and shorter, from 26 years to 21 years to 13 years, and still keep rising. So there's more and more output being done, even though there's fewer and fewer people. There are examples of factories there's a factory in the state of Tennessee in the United States. It produces 5,000 washing machines and dryers a year, and it has only 100 human employees, because everything is done by robots. So that's the type of situation that's rising. All of those 100 are paid a lot, but there's only 100 of them. That's the situation that's arising. But that's where you see the output just keeps rising and rising. The same is happening in services, as we'll see. Job loss from AI is only visible at the lower end of AI productivity. Like you'll see something that, oh, this fast food restaurant replaced human workers with a robot. Or there's this hotel in Japan where the work is done by robots instead of humans. That's one for one. And therefore the business model didn't change. But since most AI is much more than twice as productive as human output that way, the business model changes are so profound that work that gets done now is work that wasn't even being done before. So the business model changes outright. The most extreme example is, at Stanford University, we have a Stanford Linear Accelerator, and there are astrophysicists who get images from the radio telescope, and they spend 4 months analyzing all the images to look for whatever little astrophysics phenomenon they're looking for. Then, a computer vision program was developed and given to them, and what they spent 4 months doing, now that computer vision program does in 1 second. 4 months down to 1 second. That's 10 million times faster. But did that really take away astrophysicists' jobs? No, because there were never even 10 million astrophysicists in the entire world. If there were, there'd be no budget to hire them. Even if there were, how would you coordinate their work? Instead, that cost of the process went away, so they can feed it much more images. So all the astrophysicists can work more on the image generation rather than the image scanning. They say, oh, let's generate so many images that instead of 1 second, we can keep it busy for 2 seconds. 5 seconds, maybe even 10 seconds. Let's generate that many images. That's the change it is. So the demand for astrophysicists rose because of the AI, because the number of images they need just to saturate their computer vision program became much more. The business model changed, but the net jobs did not go down. And that brings us to another, little theme that I've been mentioning over the course of this presentation, government, right? If jobs are vanishing in some locations, what happens to taxes? If a person's income tax is 40 or 50%, and if his job goes away, he loses 50 to 60% of what he was making, right? Who's losing the other 40, 50%, right? The tax authority, the government. So what happens then? Are they prepared for AI doing a lot of jobs? Now, I just said how jobs are being created, not destroyed, right? Well, the geographical arbitrage opportunity becomes high there too. So AI forces governments to perhaps get into shape, as we shall see. You'll find this very odd. In the United States, the entire function of the federal government over time has become to transfer money between individuals. We thought the United States was the country that was against this type of thing, but no, not so much. Not so much anymore. 70%, and now it's actually 75 to 80% of the entire federal government is just transferred between individuals in the United States. This is $4 trillion a year, just transferred between individuals. Now what happens if you're automating jobs on one end, but more output is, untaxable output from AI is happening on the other end? See, government is not prepared because it has cornered itself in this type of situation. Payments to individuals as a vote-buying mechanism is primary function of US government at this point, because the majority of spending is that. And spending, remember, spending more than taxes. When we say it's 75% of government spending, that means it's 90% of tax collected, because spending is in excess of tax. So what does that mean? We talk about government jobs being automatable. You know, voluntarily this will never happen in any country, you know. It's the first day I've ever been in Brazil, but I can say with certainty the same issue exists in all the countries, right? But what happens involuntarily? Because when you talk about business models, right, we have a situation where AI is doing so much of the work that there's fewer and fewer human employees. Like in Silicon Valley, there are a growing number of instances where there are businesses that have $10 million revenue but only 3 human employees, because 47 humans worth of work is done by AI, right? And that means that majority of work is done by AI, but AI can be housed anywhere. It can be offshore in a tax haven. It can be in 10 tax havens the same day. It can go from Singapore to Cook Islands to Liechtenstein, all in one day. AI has made it easy for a small company to get these loopholes available only to big companies. And since more than 50% of the business output is offshore, the domicile is in the tax haven even though the humans live in the United States. AI can run circles around existing tax regime because existing tax regimes are not structured to find this. They put all these loopholes that they thought could only go to the big companies. The nature of AI, modern AI, is such that these loopholes are very easily exposed and used that way. And this becomes where the screws get tightened on government spending, because if we talk about, well, if AI is about efficiency and reducing costs, then where is the cost and efficiency the biggest problem? 1/3 of the economy is government in the world, and 2/3 is the private sector. Most technology startups are trying to disrupt a $2 to $3 billion market. Well, what if I told you there was a big disruption about to happen in a $25 trillion market? $25 trillion per year, that's how much income tax is collected worldwide. And government spending is more than tax collected, 5 trillion more, so government spending is 30 trillion a year. And artificial intelligence is attacking this on many fronts, and a lot of governments are wondering what to do because they are forced to become more efficient and to compete with each other in a way that was not possible with humans, because it's now easy to say your headquarters somewhere else even if you don't have people there because of artificial intelligence. You know, in the 1880s, they believed there was no such thing as a heavier-than-air flying machine. There was no chance of that. In as late as the 1880s, heavier-than-air flying machines are not possible, but that was possible. We have a situation now, it's not politically possible. It's not politically possible, but it's technologically and economically possible to go to 0% income tax by 2025. Just because AI is generating so much deflation that we have the ability to monetize AI, monetize deflation, so you don't tax humans anymore. That's already underway in that the world has done $22 trillion of quantitative easing through central banks, and they thought it would cause high inflation, but there's still no inflation. All that just offsets technological deflation, mostly through AI. If you're interested in this subject, I've written an online free book about that. It's a Google Talk, and it's 450,000 views. You can go to that URL and look at that. But it's about modernization of monetary policy, government, and how you can fund government through monetization of AI rather than taxation of people. So for those interested, you should check this URL out for sure. And that's why we say AI creates a resurgence of entrepreneurship. Entrepreneurship is natural. In the old days, everyone was an entrepreneur of some sort. Only in the last 150 years do we have this rather unusual system. We send people to schools where there's a large number of students in one classroom being lectured to. That's not a good method of learning. Very few retain. They always look at the clock, hoping they can just go home. And then work in a big organization. Why? Well, government likes it. Government likes people working in big organizations. Easy to keep track of. But that is not entrepreneurship. AI creates a resurgence because, as I've been saying, whenever your job is automated by AI, despite what the media is training you to think, oh, my job went away. No, the immediate reaction should be, wait, my employer is keeping that money then. The employer is saving a lot of money. I should immediately start competing with my employer. That's what you should do, because every job automated by AI is simultaneously a savings for the entrepreneur. And business models that could not exist before now become possible. For example, if you have an idea that can generate $3 million annual revenue, but it costs $4 million to do that, that's not a business, it's loss making. But if you automate that with AI and the $4 million cost becomes $2 million cost for the same $3 million revenue, then you have $3 million revenue at $2 million cost. Suddenly that's a profitable business, it's good. And the business that was not possible was because you need fewer people. You have to hire fewer people to do that. That's why the real entrepreneur would look at a chart like this and not worry, oh, where my job is. They would say, these are all the functions I can get done without paying someone now. What business can I create from this? And therefore you have these examples of $10 million revenue businesses with 3 human employees because they specifically went towards tasks that are being automated so they don't have to hire people and they save all that for themselves. So that was artificial intelligence. The one very talked about technology and how it's disrupting everything. Now we move on to the second one, blockchain, more accurately called as distributed ledgers. And the accurate term is distributed ledgers because blockchain is merely the distributed ledger for Bitcoin. So to call a distributed ledger blockchain is similar as calling a photocopy a Xerox copy. So that's a terminology issue that arises. But then what is a distributed ledger? In a central banking authority, everything would go through a clearinghouse, and we're used to it. The way banks function right now are what we're used to. But in a decentralized ledger, distributed ledger, there's no central authority, therefore it's much cheaper and much faster. The costs associated with banking is very, very expensive and very technologically obsolete, even after you employ artificial intelligence to the basic jobs of the bank. This clearing function is very outdated by modern technology standards. It's about to be disrupted. That's why all this excitement exists around distributed ledgers just for this function alone. How a blockchain works. If person A wants to send money to person B, transactions reported as a block or element of distributed ledger. The block is broadcast every part of the network, and then it becomes verified by someone on the network. But you have an immediate record. Who is sending money to whom, and who is doing the verification? Once there's a certain level of trust, then the transaction is completed. It's very, very quick. This is very, very efficient because, the credit card industry worldwide charges 3% of transactions as a fee. That's why Visa and MasterCard are among the most profitable companies in the world. There are $20 trillion of debit card, credit card transactions a year worldwide, 20 trillion. And 3% of that is $600 billion a year. That's just the fees of Visa, MasterCard, and other credit card companies. $600 billion a year just in transaction fee. Very obsolete. This could make the cost much, much lower. That's $600 billion a year of savings. And that's why there's so many companies around blockchain already and disrupting so many different things within blockchain, from mining to wallets to payments. And you see, payments is a large theme because you see multiple types of payments to the infrastructure itself. There are many, many companies doing things in blockchain right now. And then when people talk about blockchains, you hear about ICOs. It was a very volatile type of thing. ICO's initial coin offering. There was a huge boom in this from July of 2017 to January of 2018, where you would have these very unusual instances. Someone with just a white paper and a good team, they raised $240 million in 2 days. It's a very temporary situation, doesn't happen anymore. But now, you still have many companies quietly doing work and to progress. So blockchain startups with ICOs. You can see how there's a dozen or so of each, but look at all the functions that they are in. Exchanges, wallets, prediction markets, healthcare, identity and Internet of Things, payments, infrastructure, computing and storage, gambling, media and advertising. These are all the manifestations of what blockchain can disrupt in different industries. So beyond just the payment network where it originated from a cryptocurrency called Bitcoin to make payments easier and as an independent monetary authority. Now the technology is diffusing into all these things. But why is it diffusing so much? Well, blockchain generates a huge amount of data. And what always is attracted to a pile of data? AI, as we saw in the beginning. This becomes one-two punch. One-two punch against established structures that we think could never be disrupted. And you know where I'm going with this. AI and FinTech. That's where you combine the two. FinTech being financial tech, which is at the moment dominated by blockchain-related applications. And then these are companies disrupting AI and FinTech. So same sort of thing, credit scoring, direct lending, huge amount of data in credit scoring. Assistance in personal finance, quantitative asset management, huge amount of data from the stock market. Now 80 to 85% of transactions in the stock market are done by AI. Insurance, huge amount of data. Cost of insurance could fall by 2/3 just because artificial intelligence eliminates a lot of the human cost, and the data precision creates much more custom insurance policies. As costs fall by 2/3, expansion of insurance increases. Because people who don't have insurance for certain things will buy more insurance, so you de-risk more parts of the economy that way. Business, finance, general purpose, analytics, and the biggest block on the left-hand side of the screen in the middle, regulatory and compliance. So where does this bring us again? Cost of government regulation on business is very, very high. The hidden cost is so much that we don't even notice it. But you already have AI automating on one end. What about blockchain on the other? It even has its own name. For regulatory technology, it's called RegTech. You may see that word sometimes. But all these companies are just automating the compliance and regulatory burden so that it becomes something you don't even see and don't have to waste too much time on, and kind of forces a simplification in governments and international standardization of regulations too. They would never do that voluntarily, but they have to now because blockchain is forcing them to do that. And that is very exciting because, as I say, the cost of this is trillions and trillions of dollars, a hidden cost. And the efficiency gained from doing this creates a lot more businesses that otherwise would spend too much time on regulation and compliance. And this is where we get to what is very exciting. You have two technologies disrupting what is the last and biggest piece of the world economy, government and public sector. $25 trillion market. Its productivity is decades behind private sector, and the gap is getting more and more. This gap becomes untenable because you can't have a situation where tech industry produces a lot of things for free or very low cost. Like, think about it, Gmail is free, Yahoo Finance is free, Netflix is very inexpensive, iTunes is very, very inexpensive. All these things are free or very low cost, yet every business incorporation or limited liability company renewal or permit costs thousands of dollars. How can that be the case when Gmail is free and Yahoo Finance is free and YouTube is free? That is a question some are starting to ask because the gap has become so huge. That's where the exciting thing has started to happen. And I don't know if we have time for question and answers, but this is a conclusion of the presentation, but I hope it's some food of thought because artificial intelligence can help every business, large or small. You have to think about, if I can use AI to generate more revenue, front end, or get more work done with the same number of people, back end, then your profitability has greatly expanded. And even if you're a business that's not technology, you will have an insurmountable advantage against your competitors, even much larger competitors. And to learn more about that, I come back to the publication I've written, a free publication online at the URL over there. Look at that for more details and more statistics about this sort of thing. Hopefully it changes the way that you think and you get some ideas that are customized and applicable to you. And partake in the profits that are available through that, because if you're not, your competitor might be doing that first, and whoever gets there first would win. Okay. I guess we're out of time, so thank you very much.